Hi guys, welcome to my channel. Imagine you are an investment analyst looking at 5,000 companies. You don't know in advance which company belong together. You don't have a target variable saying this is a technology company, this is a defensive company or high risk company. Instead, you simply have the data, revenue growth, profit margins, volatility, leverage, and hundreds of other characteristics. Now here's the questions. Can a machine learning algorithm discover groups of similar companies automatically? Yes, and that's exactly what clustering is designed to do. Unlike supervised learning, we are not telling the algorithm what the answer is. We are asking the algorithm to discover the structure hidden inside the data. So let's begin with a big idea. Clustering is an unsupervised learning technique used to identify groups of similar observations. The important word here is similar. We want observations inside the same cluster to be relatively close to each other. At the same time, we want observations belonging to different clusters to be relatively far apart. So there are two ideas you need to remember. First, intra-cluster cohesions. Observations within the same cluster should be similar. Second, inter-cluster separations. Observations belong to different clusters should be different. Think about a classroom. If you group students based on their height, you would want students within each group to have similar height, but you also want the group themselves to be meaningfully different. That's the basic intuitions behind clustering. Let's make this visual. Imagine two groups of observations. The first group contains several points that are tightly packed together. That's good intra-cluster cohesions. Namely, the second group is also tightly packed. That's good as well. But we also want a large gap between the two groups. That's good inter-cluster separations. So an ideal clustering solution has high cohesions within cluster and high separations between cluster. This distinction is important because simply creating groups isn't enough. We want groups that actually make sense based on the characteristic of the observations. Okay, now let's bring this into finance. Suppose you're analyzing thousands of publicly traded companies. You could manually classify them: technology, healthcare, financial, industrial, and so on. But traditional industry classifications don't necessarily capture how companies actually behave. Two companies in different industries might have very similar financial characteristics. For example, they might both have high growth, low leverage, high margins, high valuations, and high stock price volatility. A clustering algorithm can identify that similarly directly from the data. So instead of asking what industry does this company belong to, you can ask which company behaves similarly based on the characteristic I am analyzing. That's much more data-driven approach. So now let's move to K-means clustering. K-means is one of the most common clustering algorithms. The name gives us an important clue. The analyst chooses a number, K. K represents the number of clusters we want the algorithm to create. For example, K equal 2 means 2 clusters, K equal 5 means 5 clusters. These clusters are not overlapping. Each observation belongs to one cluster. The algorithm then tries to organize the observations around centroids. A centroid is essentially the center of a cluster, and the algorithm repeatedly adjusts this centroid until the clustering stabilizes. And step 1 is very simple. Choose the number of clusters. Suppose we choose K equal 3. That means we're asking the algorithm to divide observation into 3 groups, and here are the important limitations. The algorithm does not automatically know that 3 is the correct number. The analyst had to choose K. This becomes one of the major weaknesses of K-mean clustering. K-mean identifies initial centroid. These are starting points for the cluster. Initially, the locations can be selected randomly. If K equals 3, we start with 3 centroids. Think of these as three temporary managed places on the data. Now every observation needs to be decided. Which centroid am I close to? Step 3. Now the algorithm examines each observation. It calculates its distance from the centroids. The observations is assigned to the closest centroid. So imagine we have a company with 20% revenue growth, 10% operating margin, and 30% volatility. The algorithm looks at the company positions relative to the three centroids. If it is close to the centroid number 2, it gets assigned to the cluster 2. And this happens for every observation. Now comes to the key iterative step. One observation has been assigned to cluster. K-means calculate a new centroid for each cluster. By taking the means of the observations assigned to that cluster, that's where the word means in K-means come from. The centroid is based on the mean value of observations in that cluster. So after the first graph, the centroids move. They no longer where they start. They now closer to the actual center of the observations assigned to each cluster. Step 5. When the centroid move, some observations may now be closer to the different centroids. So K-means repeat this process. Assign observations, recalculate centroid, assign again, recalculate again and again. The algorithm continues iterating until the clustering stabilizes. In other words, no observations need to move to a different cluster. At that point, the algorithm has converged on its clustering solutions. Thanks for watching.